So, 37. Plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. When it has gained 500 feet, find the distance to the nearest foot. The nearest foot would be the pilot's. Nearest foot the plane has flown. Okay. Where do we start? They've given us that picture. First off, what angle are we trying to find? What angle of elevation or angle of depression? Elevation, because it's going up. Okay. So it is 10 degrees. So line of sight typically is the horizontal plane. I often don't like to call it line of sight because I'm picky. What if the person is 7 foot tall? The line of sight is going to be different than standing on the. So I simply say reference plane. So in this case, it's A to C. You are here. Plane is up there. And we want to find the distance to the nearest foot the plane has flown from the runway. So that is the point by takeoff. And if you're in and we want to know the distance, we can easily find that distance because the angle is given to us. So what to do with the angle? What will you find? We have an angle, we have one length, so that is C. B. That is A. Correct. Now, if I find one of the quantities out of A, B, and C, I can easily find C. Yes. Which one should I find? But one of the two, A, B. A is known, that leaves us with B. You can use it to find C. But if you start with C, then things could get tricky. So let's just go with A and B. Last time I mentioned anytime you have angles and you want to find the angle or use the angle out of sine, cosine, and tangent, typically we use tangent. Tangent is simply A divided by B. We know theta is 10 degrees. I know that is 500 divided by B. Make sure you set it in degrees or at least multiply by pi over 180 if you're using a variance mode. What is it?
I got 2835.64.
Two 835.64 feet. That is B. If you find B, you can easily find A. Excuse me, C. C is square root of A squared plus B squared. So A is 500 square. B, the value we just found, 2835.64 square. What do we get?
2,879.38.
2,879. Exactly.
0.38.
2,879.38 feet. Here's a question. Well, why aren't we looking at AC? And why are we looking at this distance, AB? It's flying up, right? So if you were standing here with that plane was still, you look up and you want to know its distance, then it's 500. If someone asked you, well, the plane's up there, what is the horizontal distance that you traveled, then that would be the length AC or D. But it's flying up, so we have to look at the distance AB. Good. Okay. We are going to do number 59, or you will try. So a telephone pole is 60 feet tall. A guide wire 75 feet long is attached from the ground to the top of the pole. Find the angle between the wire and pole to the nearest particular. Okay, so to define the length A, to find the angle theta. No. So I have two sides already. So adjacent, opposite, work one over the length A if they aren't asking for it, or if you're not interested in knowing what that is. So adjacent divided by the opposite. My bad, thank you. I put news. So B over C, 60 divided by 75, and that would equal to what? What function of theta? Is it sine, cosine, tangent? Cosine. Cosine. So cosine of theta is 60 divided by 75. Which would be 4 over 5. But even before you start, you should sort of know what the angle would be by looking at how close this value is to 1. Yes, 4 over 5 is 0.8. And 0.8 pretty close to 1. So the angle is probably around 20, 30, maybe 40. So you can guess even before you start, because you have 0.8 and 45 degrees would be 1 over the square root of 2, which is 0.7%. So it's somewhere close to 45, maybe 30. You can guess. But how do we solve for theta? Formally, someone did this. That's like saying, I'm a person, I'll just take my head and throw it away. That's exactly what happened. Yes, you're attached, so you can't do this. So cosine of theta is 4 over 5. How do we get rid of cosine? Inverse. So if you take cosine inverse on both sides, squiggly. So theta would be cosine inverse of 4 divided by 5. And what do we get in degrees? 36.86. Suppose I want to do it in a different way. If I start with x, can you write theta in terms of x? Yes or no? Yes. If so, what is it, theta? Sine x. Well, what would theta equal to in terms of x? We'll do that first. This is from last time. 90 minus x value. Why is that? That's a complementary. So I can find x and use x to find theta. So opposite divided by hypotenuse is sine. Should you put theta or x? I'm looking this way, so it has to be x. Well, sine x would then equal to opposite 60 divided by 75, which is 4 divided by 5. Sine x is 4 divided by 5. What should you do to solve for x? Well, it's definitely right here. You take the inverse. You take
I still can't hear you right.
Yeah, Riley, louder.
You take the inverse.
Stephanie's being bossy today. Sine inverse of sine x equals sine inverse of 4 over 5. Squiggly goes away. So x is sine inverse of 4 over 5. What is that answer? degrees. Is x what we want? Yeah, no one wants the x. That's why x. How do we find theta? 90 minus that answer. So theta is 90 degrees minus x. 90 degrees minus 53.13. 36.6. Good. It doesn't matter which way you do it. It will work out. Good. As long as it is correct. Now, few ways to stop and check if you're going in the right direction. When you set sine x equals some value, that value should not be bigger than 1, which means you're doing something wrong. Same over here. you put the length of the sides, and cosine theta ends up being a number bigger than 1 or less than -1, something is wrong. As the range of time is 0 to 1. Range. Louder.
-1 to 1.
-1 to 1, the same as